This next question is considerably more difficult. It's a very nice question. It's a very good test of your understanding of forces. So have a go at this one. Okay, so here we've got a lorry that's travelling along a level road. And so the force diagram, there'll be weight force downwards and a normal contact force upwards, which are cancelling each other out because the lorry isn't accelerating upwards or downwards. So I'm just going to leave them off. But what I am going to put on is the thrust force forward. So we're told we've got a constant forward force from the engine of 3,200 newtons. I'm going to refer to that as the thrust force. And then we've got the drag force backwards. Now the car is, we're told, travelling at 25 meters per second. So that means the drag force is 2,000 newtons. Be really, really careful reading off the graph. Okay, but that means the resultant force is going to be forward, so tension minus drag. And then the acceleration is resultant force over mass as usual. And then the last part of the question is another nice little bit here. So we're wondering what's happening at a speed of 40 meters per second. So the lorry cannot travel at 40 meters per second. So why not? Let's go back to the graph. Because if the lorry was travelling at 40 meters per second, then the drag force on it would be 5,000 newtons. Now, looking back at our force diagram, as the lorry gets faster and faster, the drag force will get bigger and bigger. But once this drag force reaches the same size as the thrust, then the acceleration will have reached zero. This is essentially a terminal velocity question. And so then the lorry can't accelerate anymore, and if it can't go any faster, well, it can't get fast enough to have a drag force of 5,000 newtons. Okay, so explain why this lorry cannot travel at 40 meters per second, because the fastest it can travel is when the drag force reaches the same size as the thrust force. Any way you want to say that, because then after that the acceleration will be zero.